Kia ora. In this module, we'll give you an overview of robotics. Right, let's get started. What is robotics? So you may always hear people talking about robotics taking over the world. You may have also seen some sci-fi films with metallic robots speaking and moving in a mechanical fashion. These are the most publicized types of robots, but in fact, robots can take on so many different forms. But first, let's take a step back and look at the origins of robotics and look at the word robot, as this may provide a little bit more context about the definition of the word. The word robot actually derives from a Czech word, robota, which means forced labour, and was used in the 1920s in a play about human-like machines. In today's world, robots are not generally artificial humans, but they are machines that perform tasks for us by including some built-in computer coding. You may not even realise that most of us in fact have at least one robot in our homes. And look, I'm not talking about R2-D2 type Star Wars robots. I'm actually referring to things like the washing machine. Some washing machines have humidity sensors and they're programmed to detect the moisture in your clothes, for example, and change their washing technique accordingly. Another increasingly common household robot is the vacuum cleaner. And it can be used to clean a floor on its own using algorithms that help it to navigate around different spaces. As you can see, robots come in all sorts of different types, of different shapes and different sizes. But why do we actually need robots? I can do all these tasks on my own, but of course they'll take me a lot longer. So the great thing about robots is in fact that they can take on boring and repetitive tasks and free us up to do more interesting things. Perhaps the most important use of robots in today is industry. Manufacturing these days makes extensive use of robots to make products, including those that are washing machines or vacuum cleaners. Currently, and going forward, many jobs in fact will become automated. And this will allow us the opportunity to focus our efforts on much more exciting projects. All kinds of robots will be taking on tasks such as driving and flying and farming. Robots actually make our lives easier. So let's take a look at how they work. There are many different types of robots that are suited for students to learn about robotics programming, such as Edisons, Mbots, Lego Mindstorms. For example, let's take a look at how to program an Mbot using a program tool called Mbot. This software is very similar to Scratch, in which we introduced you to in earlier workshops. Mbot is block-based coding, so you connect the blocks together in order to create instructions for your robot to follow. We're now going to show you a little simple example of how to program an Mbot to behave like one of these robot vacuums that we talk about. And what we want it to do is to sense when it's near a wall and navigate around a room. Here is some of the code that we've put together in Mbot. As you can see, it looks just like Scratch. The main difference is that Mbot can download your code to the robot. We're not going to take you through how this code was actually put together right now, but you can see how we built it in this activity. The main idea here is that we can use the ultrasonic sensor that sits on the front of the Mbot to detect when there is an obstacle in front of it, such as a wall. When the Mbot senses an obstacle, it turns. It moves along a little, then it turns again to go back in the other direction. The code also checks to make sure that the robot doesn't keep turning in the same direction. Imagine if you had a robot vacuum cleaner that always turned right when it met an obstacle. It would keep going back over the same bit of floor again and again and again. That's why our code switches each time between turning left and right. Of course, real robot vacuum cleaners use algorithms in a lot cleverer ways than this one. But hopefully this simple example gives you an idea of how robots can use programs and sensors to perform different and useful tasks. When programming a robot, it's important to understand the difference between a remote control and having a robot operate on its own. When we use a remote control and press buttons to control a robot, we're thinking for the robot. In true robotics, the goal is to get the robot to make its own decisions. The robot should then be able to respond to its surroundings, like the simplified vacuum example that we gave you earlier.